Welcome in the fourth video of elementary particles. In this video, we discuss about hadrons. Hadrons are the particles that experience a strong nuclear force. This means they contain quarks. A hadron is defined as a particle that is composed of any combination of quarks or quarks and antiquarks. There is two subcategories of hadrons: standard hadron, exotic hadrons. Standard hadrons include mesons and baryons, whereas exotic hadrons quark combination consisting more than 3 quarks. Meson and baryon were derived from Greek word baris meaning heavy and mesos means intermediate. If we're making an analogy to the animal kingdom, the term hadron represents to animal while the term meson and baryon represent to mammal and reptile respectively. A meson is made of one quark and one antiquark. We will cover meson topic in next video. Here we focus on baryons. Baryons are made of 3 quarks. Baryons again divided into two categories: nucleons and hyperons. Nucleon consists neutron and proton, whereas hyperons consist sigma, delta, chi, lambda. The various combination of quarks lead to variety of different baryons. Physicists classify baryons into 6 families based on the quark's content and relative spin state of the quark. Let's talk about baryons property. Proton is made from up-up-down quarks, whereas neutron from up-down-down quarks, whereas lambda contain up-down strange quark combination. Sigma in 3 forms: sigma positive, sigma naught, sigma negative, with up-up strange, up-down strange and down-down strange quarks combination. All these have half spin: delta positive positive, delta positive, delta naught, delta negative, have same masses. In these, up quark change into down quarks. All these delta have 3/2 spin. Chi naught and chi negative have quarks up strange and down strange respectively and spin half. Omega consists all 3 strange quarks and 3/2 spin. Last one is charmed lambda, consists a combination of up, down and charmed quarks with spin half. Since there are 6 flavors of quarks and 3 quarks in each baryon, there are several dozen possible baryon combinations, but the universe is made entirely on 2, the proton and neutron. Protons are composed of 2 up quarks and 1 down quark, so the charge of a proton is +1. A neutron is composed of 1 up quark and 2 down quarks, which results its net charge of 0. The neutron is slightly heavier than the proton because the down quark is slightly more massive than up quark. The lambda is a baryon composed of an up quark, down quark and a strange quark. By adding the charge of quarks, we can see the lambda is a neutral particle, but it has a strange quark instead of down quark. As strange quark is more heavier than a down quark, thus lambda is much more massive than a neutron. The type and mass of baryon depend not only on composition of quark flavors but also on their arrangements. For example, the neutral delta particle is a baryon made of 2 down quarks and 1 up quark, same as a neutron. The spin of neutral delta is 3/2 rather than 1/2 because all 3 have same spin alignment in the delta, producing a high energy state results in higher mass. Sigma is a baryon which contains strange quark. The neutral lambda baryon is less massive than the sigma baryon. Omega baryons are either neutral or have a charge +2, +1 or -1. These baryons containing no up or down quarks. Chi baryons have an electric charge +2, +1 or -1. These have first quarks from first generation and other from higher generation. Firstly, Manchester group discovered chi baryons in cosmic ray experiment in 1952. In addition to charge and spin, baryons also have quantum property called baryon number. This is important because baryon number is conserved property just like energy, charge, spin and lepton number. The total number of baryon before and after remain conserved or unchanged during interaction. All baryons have a baryon number positive 1 as baryons made from 3 quarks. So baryon number for all quark is positive 1 by 3. Conversely, antibaryons and antiquarks have a baryon number -1 and -1 by 3 respectively. As strange quark has a number of strangeness -1. Strangest number. It is also a quantum property of baryons. Its value depends upon the number of strange quarks present in the particle. Here we show nucleons have a 0 strangeness value, lambda has -1, sigma has -1, delta has 0, chi hyperons has -2. On the basis of strangeness and charge, there is baryon octet and another figure which represent these very well. Thanks for watching. In next video, we talk about mesons and decay of hadrons.